Go me. Okay. Hello and welcome to my Festive Tech Calendar 2021 talk on event sourcing with Azure Cosmos DB change feed and Azure Functions. Today we'll take a look at how we can help the elves track every event that happened this holiday season. Okay, let's go to my slides. Okay, so a little bit about me. My name is Callon Campbell. I'm a four-time Microsoft MVP in Azure and have 20 years experience in enterprise development with C#, Azure, SQL Server, and I guess a long time ago with mobile. I'm passionate about serverless and cloud-native application development and bringing those benefits to the enterprise. I'm a speaker at local community events, meetups, and Global Azure Bootcamp. I also run the Canada's Technology Triangle.net user group here in Kitchener, Ontario, Canada. And I blog at theflyingmaverick.com when I have time. So to the agenda of my session. So I'll quickly, do an overview of what is event sourcing. I'll then get into an introduction of Azure Cosmos DB change feed. We'll then look at using the Azure Cosmos DB change feed as an event source and consuming it with Azure Functions. Have a bunch of demos, and then we'll wrap up. Okay, so what is event sourcing? Martin Fowler describes event sourcing as is a data pattern that ensures that all changes to application state are stored as a sequence of events. Not just can we query these events, that we can also use the event log to reconstruct past states. So instead of storing just the current state of the data in a domain, we can use an append-only store to record the full series of actions taken on that data. So let's look at the event sourcing pattern. So on the right here, I have an example, shopping cart. So if we take an overview of the pattern, some of the options for using the event stream are create a materialized view. We can integrate events with external applications and systems. And we can also look at replaying events to create projections of the current state of specific entities. So events are immutable and can be stored using an append-only operation. Events are simple objects that describe some action that occurred plus any associated data required to describe the action represented by the event. The append-only storage events provides an audit trail that can be used to monitor actions taken against a data store, regenerate the current state as a materialized view, or use projections by replaying the events at any point in time. And lastly, the event store raises events, and tasks can perform operations in response to those events. So this decoupling of tasks from the events provides flexibility and extensibility. So if you look at the diagram on the right, as each item is added to a cart, so we create a shopping cart, we add different items to it. We might remove something, we'll add the shipping information. So all of that is persisted to an event store. In this case, for my demo, I'll be using Cosmos DB as that event store. And then as those events happen, we can, use a materialized view to show the current state of the shopping cart at any point in time. Those events can go out to external systems and be consumed. And we can also go back and replay the events that happened for that shopping cart experience if ever needed. So using Cosmos DB as an event source. So the change feed in Azure Cosmos DB is one of the most overlooked features in Microsoft's globally distributed, scalable, and multi-model database service. Similar to the transaction log of a relational database, the change feed is a persistent record of changes to a container in the order that they've occurred. It therefore serves as an excellent event source for a wide range of cloud-based microservices targeting eCommerce systems, IoT, and many other large-scale scenarios. So Cosmos DB is a great choice as a central store where all events are modeled as writes. In this scenario, we'll have full record of past events in the change feed. Okay, you can have multiple change feed consumers subscribe to the same container's change feed. I'll show that in the demo. And the change feed processor library ensures that you don't miss any events with the at least once guarantee. So in Cosmos DB, the change feed is enabled by default across all accounts. It's a persistent record of changes to a container in the order in which they occur. And there's always the latest version of the document being stored. You can also replay the change feed from any time since the container creation. So some typical change feed scenarios. We have event computing, and notifications. So as events happen inside the change feed, we can have it triggered to an API that could be running in Azure functions. Maybe we're notifying Azure notification hubs or app service. There's stream processing. So this is real-time stream processing of that data. We can use such tools as Azure Stream Analytics, Azure HD Insight, Apache Spark or Apache Storm. And then we also have zero downtime migration. So this is very handy if you need to move data. So if you want to copy data into a secondary Cosmos database instance, you can. You can move it to Azure Data Lake. You can move it into other cold storage options like Azure Storage Blob or Azure Storage Table. And then that way you don't keep the data always inside of Cosmos and have it much cheaper inside of storage if needed. So for my demos today, I'll be demoing the first one, so event computing with Azure Functions. And then I'll also be doing some data movement scenario where I'll copy the data from the change feed into Azure Storage Blob. Okay, so what are some of the limitations of using the change feed? So the change feed is not a full operational log. So one of the things I mentioned earlier is that you only get the latest copy of a document. So if I create a document, let's say I create an order, the quantity is 2. I then update that order and I set the quantity to 5. I then go into and delete the order. I don't want it anymore. So I'm always going to have the latest version of that document. In this case, 5 was the latest version. So I'm not going to have the full history, full operational log. There is a feature coming in Cosmos DB. I believe it's still private preview right now, but there's an option that you will have in the future if you so choose to want to use it as an operational log. So now with updates, there are some limitations. So again, only the most recent change of a given item is included. So this is not really suitable where you need to go and replay past events. Again, if you're updating documents, you will only ever get the last one. Most of the time that's suitable, but for certain scenarios where you do need to have the create and the update to 2 and the update to 5 example, then there's other ways to go around that. And again, with deletes, so deletes are not captured and written to the change feed. So a workaround for that is use a soft delete property. So on a document, you could have is deleted, set that to true. So you will capture that information. And then you can set the TTL, so time to live. And then Cosmos will automatically delete the document when the TTL expires. And that TTL is just number of seconds until it expires. And the last limitation is guaranteed order. So there is a guaranteed order in the change feed within a partition or a partition key, but not when you have to go across partition keys. So it's very important that when designing your Cosmos DB, take a look at partitioning and make sure you design your partition properly to get around this issue. Okay, consuming the change feed. So our first way of consuming it is just directly, using low-level API access. You have to do all the work of managing which partition you're talking to. Not advisable, but it is there if needed. Second model is a pull model. So this model is scalable. It is a manual pulling process, and it only gives you a single partition key option to work on. The best approach is use the change feed processor library. So this is stateful and is fully scalable. It handles all the underlying logic for accessing each of the partitions. So this is the preferred way if you ever need to talk to the change feed. And if you're working with Azure Functions, then Azure Functions is a serverless wrapper around the change feed processor library. And that's just by using the Cosmos DB trigger Azure function. You will get automatically triggered of anything that happens inside of Cosmos DB. So it really makes it really easy to integrate. And quickly, just supported APIs and client SDKs. So change feed is pretty much supported across the board with the exception of table API. So I'll be doing my demo in .NET, .NET 6 to be specific. But any other language that you're coming to, Java, Python, Node, and I'll be using the SQL API, but it also applies to Cassandra, Mongo, and the Gremlin API as well. Okay, quick time check. Good. Okay, so for our particular application scenario, again, I said we're going to try and help the elves track every event that happens this holiday season. So what we're building is a real-time flight information tracker for Santa's current location as they travel on Christmas Eve across the world. So basically, we're simulating like an IoT ingestion of events. So we'll be tracking, current location, speed, height, cities that they visited, etc. So that's going to be a high ingestion rate of events coming into Cosmos. We'll then have a change feed. We're going to have 3 different microservices running as Azure Functions. And what they're going to do is they're going to pull up what's the current location. Another one's going to pull up sort of a delivery board showing all the cities that Santa's already visited. And both of those are going to use the Materialized view pattern. And then that's going to get consumed by a Blazor WebAssembly application that's using an Azure function API as the backend. And that API is going to be querying Cosmos every second to update the dashboard and show what's happening. The third microservice will be data archival. So as the data comes in, where Santa's been, all that kind of information, that's not really needed after a certain period of time. So what I'll do is I'll show how we can archive that information off into storage using Azure function. And then the change feed will just delete the data when needed. So this whole application, I have it up on my GitHub. I'll make it available. It should be available by the time this goes live. So take a look, reach out to me if you have any questions. Okay, so ingesting telemetry. We're going to have a container called location. It's going to receive the flight telemetry. Telemetry is going to be coming in every 10 milliseconds. And basically, it's going to be one flight. It's just Santa flying across the world, but it's going to be doing flight segments. So the segment is basically between the leg between 2 different destinations. I live in Canada, so I'll be tracking Santa as they fly across Canada from East Coast to West Coast. And we'll be tracking, again, their location, the speed, altitude, current city, where they're heading, that kind of stuff. The partition details, I'm going to be creating a partition key on ID because this is ingesting the telemetry. I want to, using ID, which is a GUID, which will be defined as a GUID. It's going to optimize for bulk loading of that data and make sure it's distributed evenly across all the partitions. Okay, so let's get into a demo and show that information, or just show how I'm doing that. Okay, so I have my Azure function application here. I'm going to go into the data generator. So there's just a console application. So when it starts up, again, I'm collecting data every 10 milliseconds. Santa's flying at 5,000 miles per hour. I need to make this quick for the demo. Whole demo takes about 3.5 minutes to fly across. And then I'm going to keep the data for about 30 days for the data archival period. So these are a bunch of cities that I'm going to be loading. So when I start the application, I have the option to just blow away and recreate my Cosmos DB completely if needed. And it will load all this information in here. When it goes and creates the containers as part of the loading, These are the 5 containers that I'll be creating, and I'll switch over to the portal to show this in a second. But I'll be having my location container. This is going to have a partition key of ID. I have a throughput of 1,000 RUs a second. I am going to do auto scale on that container, and time to live I've set to null. All the other containers, with the exception of the lease, are going to have a partition key of type, and the throughput them are going to be 400 because the amount of data I'm pulling, or I'm not really inserting, but pulling from there is not that much, so I don't need to have a high throughput level. Everything here, this is pretty boilerplate when it goes and creates the flights. I'll come back to that. Okay, and then let me switch over to the Azure portal here. Okay, so in the Azure portal, I have my Santa Tracker Cosmos database called Santa Tracker. So here's my 5 containers. Again, here's my location container. So this is the one that's going to be ingesting every 10 milliseconds where Santa is at all time. Each one of those records is just going to append. So it's just going to add a new record for every single event of where Santa is. I can look at some of the historical ones. You can see the ID is a GUID. The type of document, I've given it a location. And then I have other information, you know, what route number it is, what departure city, where's the arrival city coming, how long it's going to take in minutes to do that flight, the distance, speed, altitude, all that information. And then have is complete. That's an important property I'll come back to later. And then time to live will be set for how long I want that document to be retained for. The other ones I'll come back to. Metadata. This is a simple just lookup container. So some of the information I'm going to load into here. So here's all my cities, information about them, and then each one of my flight segments are in here. So I can very easily put all this lookup information into a single container and partition it by type, and then all that information will always be in the same logical partition. Okay, so let's go back to the demo. I'm going to run it now. Of course, it starts up on the wrong screen. Okay, so let me move my function app windows. Okay, I want that one up here. Okay, so right now I have, these are my 3 different function microservices. So we have the current location, we have the delivery board, and we have the data archival. I can go, and then we have our Blazor web application in the back. We can see that Santa is currently at the North Pole. He's coming, he hasn't visited any cities yet, and system status, you know, things are green. Some of the departments are starting to shut down as they get ready for the big day. I do have my 4th microservice, and this is the API for the Blazor application. So it's querying every second, going to Cosmos to find out what the current location is or what's happening. So what I'll do now is I'm going to start up the generator, and then we'll see things change. So we can see my microservices have already kicked in. My delivery board or my mission control board is already starting to show where Santa is. He's traveling from St. John's to Sydney, Nova Scotia. So as each city is visited, it will be added under the cities. Now he's heading to Charlottetown, Prince Edward Island. And then each of the 3 microservices are running now. So the yellow that you do see, let me pause that, is just an event that's happening. So, you know, upstream location to a materialized view. This one is already archiving some data, so saying it's a storage account. And this one is just also upserting the location event to another materialized view. Okay, so I'll let that resume. And we'll come back to the demo as it's done. So each one of those microservices are all independently happening and receiving that data on the change feed independently. I can start and stop each of those microservices, and they will retain the location, the pointer of where they last were. So if you want to stop a microservice, if you want to stop the change feed from being processed, you have the options of doing so. So let me let that keep going. Nothing's going to change here other than cities visited. So let's go look at some of the code. Let me check the PowerPoint. Make sure. I'll come back to the PowerPoint, finish that part off. Okay. So consuming the change feed. So again, as I mentioned, I have 3 different Azure function microservices. Each microservice is scoped to the change feed. And then what I'm doing is the data coming in is at 10 milliseconds. So what I'm going to do is add some throttling in there. I don't need to update the board every 10 milliseconds. So what I'm doing is I'm taking a snapshot of the data every, depending on which microservice it is. I change the settings, but every between 3 and 15 seconds, I'll capture the data. So all I'll do is I'll go into a thread lock, update an in-memory dictionary of what I'm doing, and then record that information. So the lease container, this is a container that keeps track of all the consumers that are working on your working off of the change feed. So it's required when you consume the change feed through the change feed processor library or when using Azure Cosmos DB trigger. It will automatically get created if you don't create it yourself. In the lease container, an item is created for each physical partition and to bookmark the latest item that was processed. And again, that is for each client. So in this case, I'm going to see 6 entries, 1 for each client and 1 for the physical location partition and last item that was processed for each one of those clients. And for this, the partition key should be ID. So in general, when you create this container, 400 RU should be enough. For very large workloads, you might want to increase it to maybe 1,000 or 2, a few thousand at most, or switch it to auto scale if need be. So taking a look at the lease container, so we have our Cosmos DB, we have functions that are reading off in it, and they're all sharing, in this particular example on the right, they're sharing a lease container, but that's not the case. You could actually have a lease container 1 per function, but ideally you would want to have one that you shared. This makes better use of the provision request units of that container, and also allows you to scale that out with Azure Functions to use the same provision throughput. So when configuring a shared lease container, inside your Azure function, these are the attributes that you're going to use for what's the name of the database, what's the name of the collection that you want to be monitoring, your connection string. Then for your lease collection information, you want to put the name of the container. So I'm just using lease. If you're going to share it across multiple consumers, then you want to use the lease collection prefix. So in this case, I'm just putting a current location dash. I'll have a delivery, a dashboard dash, and I'll have a data archival dash. And those will be my different prefixes. Again, if you're going to put in each client has its own lease container, then you don't need to prefix for that. You can also create the lease container if it doesn't exist, and the Azure function will do that for you. Okay, so let's go back to the demo now and see how we can consume that. And if we go back to the demo, I think everything should be done. Santa has left Canadian airspace. Okay, good. Okay, so the first one I'll look at the current location. So in here, you could put this all in the same function app, these 3 different microservices. I spread them out. It's good to have the isolation of, if you need to bring one of these microservices down, you can without having to bring the entire application down. and things in Azure are cheap, so you can stack, these into an app service plan. That is make it quite dense. Okay, so we go to functions, Cosmos DB trigger, current location. So here's the prefixes I mentioned. So our database name, these two that I have commented out. So if you want to process your change feed from a different point in time, so start from the beginning. You can put that to true. When you start up, it will go from the very beginning. False is the default. And if you want to go from a particular point in time, maybe I want to go back to yesterday, 24 hours ago, then I could enable this and just put in a particular time. Again, that's optional. And the time format is in ISO 8601 format. So basically what you're looking at now. Okay, and when this trigger happens, you'll get a collection of documents. It's not going to be the entire collection of documents of what changed. It will just be a collection. And what's really nice about this is Azure Functions will scale out to meet the demand of the collection coming in. So I'm going to get the container of my container that I need. So I have the Santa tracker as my database, and I'm going to go and get the current location container. And then I'm going to go for each one of those documents. I'm going to update the current location. So I'm going to deserialize the document to a location event. I don't want to, save every single document I'm getting every 10 milliseconds. So I'm going to go into a should skip and I'm going to check. So if is complete is true, so that's the very last event happened for that flight, then I definitely don't want to skip that. So I want to, capture that information. If not, then what I'm going to do is go into a thread lock, and I'm going to store the last time this event happened for this particular flight leg or route number, I should say. And as long as it's within, under 5 seconds, then I'm going to skip it. Otherwise, I'm going to go and process the data. So when processing the data, so when the data was being adjusted into the location container, the ID was a GUID, so everyone coming in. But now when I'm tracking, I'm putting this information now into a materialized view. And so the current location, it's going to be, there's only one flight. It's by year, so 2021 flight. Only going to be one document. So I'm going to change the ID to 2021, which is the flight number. And I'm just going to keep updating that document with the current location that I'm getting. Now, if we go back to the Azure portal, and I go to the current location, we can see I only have one record in here. And this is always going to be the current date. And as you can see here, the flight is finished, or at least this flight in terms of what I'm tracking is done. It is complete is true. So I always got that information. So I don't have a whole record here. And this is very, very quick when I want to query this information to go from a materialized view rather than going off of the actual location container, which will have hundreds of thousands, if not millions of documents. And actually, let me show you that. Should I go back to the... Okay, so just going to get a query of the total count so you can, for scale. So I only have, just 187,000 documents is what I'm really querying of. If I ever say, go get me the last item. So most people might say, well, I'll just run this query here, get current location from the location container. So select top one, where the flight number is 2021 and order by the timestamp. So that will come back. It does return back my data, but it's coming back in, where's the RU? So 2.97 RU is what that is costing me. Now, typically in Cosmos DB, when you look up one item, it should always be 1 RU. 1 RU is very, very cheap. Anything more than that, if you're looking up one item, you're doing something wrong. So in this case, if I need to look this up, it's going to be 3RU. If I was tracking more than one flight, then that would be 3RU, times, X number of flights that I'm tracking. In this case, I'm only tracking one flight because it's Santa. But if I was tracking, show me all the locations he's currently at, then that would be more expensive to go at. Which brings me to the next part of the demo, and that is the delivery board. So the delivery board, this is another microservice Azure function. Again, it's being triggered off of the same container, the location container, and it's using the delivery board as a prefix. It's going to cycle through every document that comes in. Again, this will scale out. I'm going to check whether I should skip. If it's under 5 seconds, I don't need to know about it, right? So I'll just get the latest. I'll get the update every 5 seconds, essentially what that's doing. And I'm changing the ID for when it goes into this particular container. Is I'm going to have one document per leg of essentially for every city that Santa goes and visits on the 24th. So as it goes through, it's going to update. If it's the same city, it's just going to keep updating that document. If it's a new city, it will create a new document and then upsert that as needed. So very similar to the first demo. And if we come back in here and then I say, if I wanted to write a query, board. So this one here is only ever going to have one document per location. So as you can see here, it doesn't show count, but I got 22 locations. As I track across Canada, and then Santa leaves Canadian airspace. So one of the queries that I'll be using from my Blazor web API on the dashboard, it will be a query like this. And this will be like, get me the current location of all those cities. Because the partition key is going to be on type, it's very easy for me to go and say, get me all these cities, because they're all going to be in the same partition. And the query stats that will come back, less than double what a single item was when I'm querying the main location container. So for something like that, this is 5.91. This might increase, might decrease, depending on how big your container is, how many cities that are in there. But it'll still be very, very cheap versus if you just went and ran a similar query against your current location container. Okay, and then for the third demo, this will be the data archival. So again, another Cosmos DB trigger, time check. So again, I have a data archival prefix. I'm going off the exact same lease container. For my demo, I'm always going off of the location container, but I could have different functions in here that are going off of completely other containers. So I could be triggering off, flights that go into maybe the other two materialized views. So anything that happens in them, I could be triggered on. So it's not always the main container that you need to worry about. Very similar logic. I'm going to skip. I don't need to put every single event. I always want to put the last event into storage. And then all I'm going to do, very boilerplate code, is, if you ever worked with Azure Storage Container, is I'm going to take that document, serialize it, and stream it into upload it into Azure Storage as a JSON document. Let's see, anything else I can need to show? For my examples, all my functions, I'm doing dependency injections for each of them. So I'm loading in singleton for talking to Cosmos. In the case of the data archival, I'm loading a singleton for Cosmos, and I'm also registering a singleton for the blob service. I'm storing all my secrets inside the Visual Studio secrets files. So in my host, the local settings, there are no secrets being stored. I do put down the port number for each Azure function since I'm running them all at the same time. But yeah, no other than secrets to the Cosmos DB and to the connection string, that's it for my applications. And then I have a shared library, and this library is being shared across all my Azure Functions apps, and including the Blazor application, which is really, really neat to do that. Okay, let's go back to slides and see what I've missed. Okay, real-time flight location query. So getting the current location, partition key, I think I went through this. So doing this would be very, very expensive. Because it would result in a cross-partition query. So by moving it to a materialized view, it's going to be a point read, which will mean the RU cost will be 1. Okay, introducing materialized view. I think I covered this, but let's see. So basically, it's used to generate pre-populated views of data in environments where the source data is not in a well-suited format for querying the application. So put it into a different state. You could have just an entire copy of a container into another container that is more optimal for querying based off of other use cases. In my case, it's a very, very tiny view. It's only 1 document per flight or 1 document per segment, so city visited. And that way, all those documents are going to be in the same logical partition, so I'm not going to be doing any cross-partition queries. And by doing this, it's going to make it really, really cheap. So 1 RU for basically a 1 kilobyte document. So we did that demo, and we did that demo. Okay. So in summary, Cosmos DB is a great choice as a central store where all events are going to be modeled as writes into an event sourcing pattern. This uses the strengths of the horizontal scalability strengths and high availability that Cosmos DB provides. You can consume the change feed using either the change feed processor library or from Azure Functions. Those are the 2 preferred ways. The other 2, not so preferred, but they are available if needed. Each of the consumers can be stopped independently. And actually, I'll go back because I missed that. I'll finish off this slide. And they can be replayed from an earlier point in time. And by using the materialized view pattern, you can generate these pre-populated views. Okay, so let me go back to Windows is not working the way I want it to. So the last container, which I did not show, was the lease container. So in this container, you can see I will have 2 documents for each of my clients. One of them will be showing where the current partition is, and the other one will be showing the last pointer of the record that was read. So that's really it. So the change feed is really, really powerful scenario in Cosmos DB. And when you tie that together with Azure Functions, it's really amazing some of the applications that you can work with or build. Yeah, so let's go into finish off my presentation now. So references, I provide links to learn more. If you have any questions about my talk, about the topic for Cosmos DB, Azure Functions, any questions on Azure related, feel free to reach out to me. Have my email, reach out to me on Twitter if you want. And again, the source code will be up on GitHub. So that's it. Thank you very much for my talk, and wish you all the best this holiday season. Cheers.